Hello guys, I'm Anish Jagdare. Yesterday I just uploaded my video on errors, and today I am going to teach you about motion. This is the second chapter of 11th standard, and it is a very important because it forms the base of whole 11th standard and 12th standard. And this also comprises of some basic equations which are very important, and these are known as equations of kinematics. And these equations of kinematics are very important, not only for 11th and 12th but also throughout your whole life, because these are derived by famous scientists like Newton and Einstein. The first one, I'm just going to now explain you all the equations in briefly, but after 5-10 minutes I am going to also derive them one by one each. Now the first one is v is equal to u plus at, where v is equal to the final velocity. If a body is in motion, then its final velocity is always denoted by v. When it stops or before it stops, the final velocity is always denoted by v. The u is initial velocity, means if a body is at rest and it starts walking and it covers a distance of 10 meters in 10 meters per second, that means in 1 second it travels 10 meters, then the final velocity will be the final velocity will be the 10 meters per second, while initial velocity will be 0 meters per second, because it was at rest. That's why initial velocity was 0 at starting. While a is equal to acceleration. Now everyone will think that what is acceleration. Acceleration is actually the change in velocity per unit time, and its formula is velocity upon time square. That means, velocity upon time, and its formula is we can derive it easily. Meter per second upon second is equal to meter per second square. Its formula is meter per second square. And this is not important because I am going to teach you, tell you all about that afterwards. Now S is displacement, and these all terms you should note down because these are very important, and if you are not knowing the full form of these all terms, then everything I will teach will not be understood by you. That's why I am telling you this all short forms. Now the first equation is v is equal to u plus at. The second one is v square is equal to u square plus 2as. The third one is displacement is equal to v plus u whole bracket into time upon 2. And the fourth one is displacement is equal to u initial velocity into time plus half at square. And these all are kinematic equations. And I am also going to talk about some basic principle of motion. Now let's get started. Now we are going to derive the first equation, v is equal to u plus at. Our task is to derive it, but this equation not has a proper derivation, because it is just found by Newton in how our daily life work. From that, this equation is found. For example, if I purchase 5 eggs per day, 5 eggs per day for 15 days. Okay, now I will ask you one question, that on the 15th day after purchasing 5 eggs, on the 15th day, what will be the total number of eggs with me? Okay, now how you will calculate that? 5 eggs per day, that means you will simply multiply this 15 into 5, 75 eggs. Okay, 75 eggs. Now these 5 eggs per day is your acceleration. Okay, initially you had 0 eggs. And you are accelerating that eggs with 5 eggs per day. That means 5 eggs are adding each day. That means first day 5, then 10, 15, and so on till 15th day. Okay, now this was acceleration. First you added 0 because initial velocity at 0. If I will say that I had 10 eggs initially, and from that day I started eating 5 eggs per day till 15 days. How many eggs I ate? that means 10 plus 15 into 5. If I had 10 eggs initially, that was my initial value. So but in this case my initial value is 0 because I have no eggs. Right now I have no eggs, my initial value is 0. I will consider it as u because it is initial velocity, so I will consider it as u. And this is my acceleration and this is my time. So how you calculated the total number of eggs that I have collected in 15 days? Final velocity, that means on the 15th day, final is equal to this 0 plus 15, that is time, 15 into 5, 15 into 5, which is same like this, v is equal to u plus 80. So this was very easy because it is derived by our day-to-day activities. And I will take one more example for this. If I have 10 apples right now, I have 10 apples right now. I purchase one apple per day. 10 days I purchase one apple per day and I have 10 apples right now. So what will be our initial velocity? 10, acceleration 1, and final time 10 days. So we have to calculate the number of apples on the last day. So I will calculate it like this: v is equal to u plus 80 by using this formula. We will check it if we will get it correct or not. 10 plus 1 into 10 equal to 20. It's easy maths. One day, one apple per day, 10 days, 10, and I have initial 10, 10 plus 10, 20. So that, by this the Newton derived this equation, and this equation, this one is the basic one, and it forms the base of everything. Now derivation of the second equation, v square is equal to u square plus 2as. Okay. Now this equation, if I will consider a body, if this is a body and it is at rest, what do you understand by rest? That means it has initial velocity 0. Okay, initial velocity 0, and its kinetic energy, we will consider an I, kinetic energy, initial kinetic energy, it is also 0 for now, because and it is equal to half m u square. It is actually half m v square, but now here we are considering initial velocity, so we can consider it as u square. Okay. Now if I apply an external force and I do a work on it, if I apply external force by doing a work on it to make it move, and it travels some path by some distance, okay, it travels a distance, and here it has a final velocity. It will not have an initial velocity because it is traveling, it is not stopped at one place. Okay. Now this is not stationary, and I will consider its kinetic as final kinetic energy. Okay. Now we have done a work on a body at rest to make it move. This is, and we will write it in mathematical equation. This kinetic energy is equal to initial kinetic energy plus work done. And this is because Einstein said that energy can neither be created nor be destroyed, but can be transferred from one form to another. That's why this is always equal to this. Okay. Now I will rough it so that we can. Final kinetic energy is equal to initial kinetic energy plus work done. As you know, work done is equal to mass into acceleration into displacement, whereas this is force. Force is equal to ma. Force is equal to ma. Okay. Now, and kinetic energy's formula is half m v square, while kinetic energy initial kinetic energy is equal to half m u square, and final kinetic energy is equal to half m v square, because we have considered final velocity and initial velocity. Okay, now we will substitute all these values 1, 2 and 3 in this equation. Okay, half m v square is equal to half m u square plus m a s. Alright, now I will write it once more. V square is equal to half m square plus 2 by 2 into, I can divide it and multiply it by 2 because it will make no difference, it will get cut at last, but I am doing it for some specific reason, so that I can take 1 by 2 m common from here. So this 1 by 2 m v square is equal to 1 by 2 m u square plus 2 as. So this and this will get cancelled, and I will write this above here, and we will get it as v square is equal to u square plus 2as. We have derived it. Okay, now this was the second one that we derived, and this is not so complicated because the fourth one is actually complicated. Fourth one is complicated. Now we have derived two equations that are v is equal to u plus at and v square is equal to u square plus 2as, and this is only in the case of acceleration. Okay, and if it is retardation, that means deceleration or retardation, then these equations will be v is equal to u. Always retardation or deacceleration is in minus, so minus a into t, so v is equal to u minus at. Same here, v square is equal to u square minus 2as. In deacceleration, this will be, both the signs will change to minus. Okay, now I am going to derive the third one. This is v square is equal to u square plus 2as. V square is equal to u square plus 2as. I can write it as v square minus u square is equal to 2as. Now, in 8th or 9th standard, you may have studied that a square minus b square is equal to a plus b into a minus b, and this same form is possessed by this one. So I can write it as v plus u into v minus u is equal to as. But here you can see that if we shift this v here from this equation, we get v minus u is equal to at. So we can substitute this here. V plus u at is equal to as. A and a get cancelled. So we get displacement as v plus u into t divided by 2. And this was the third equation that I have proved. You can note down it if you want. I will stop for a minute, or you can pause the video. Okay, now the fourth and the last one, that is displacement is equal to ut plus half t square. Okay, this is the last one that we are going to do, and I will just get a recap because this is a very long explanation and it will take some time. So first we will do the recap of the first three, then we will go on this. The first one was v is equal to u plus at, and also v is equal to u minus at, because this is the acceleration and this is acceleration. So v square is equal to u square minus 2as. V square is equal to u square plus 2as. Displacement is equal to v plus u into t. It will remain same in both cases. It will remain same. You can note it down if you want it. I will stop for a minute. Okay. Now we have to prove this one. So we can also write it as, now where is that? Now v plus u, all this, okay. Now we have to take this third one here. For this derivation we need all these three. That's why this is the important one, because it comprises of all these three equations. And write here dot s is equal to v plus u into t upon 2. Okay, clear? Now v, I have the here v, value of v, u plus 80. I can write it as here u plus 80 plus u upon t divided by 2. Okay, so s is equal to 2u plus 80 into 2t on 2. Right? Now s is equal to ut plus 80 square. There is no need of explanation of all this, because this is all basic maths. You may have studied it in 10th or 9th standard. Now I'm rubbing it, because you can just pause the video and note that down. I will just note this up here. Displacement is equal to ut plus 80 square upon 2. Okay. Now I'm going to separate this 2ut upon 2 plus 80 square upon 2. 2 to cancel. So we get this equation. Same equation, ut plus half 80 square. So this one was the important one in all three, because you can solve many problems of 11th and 12th from this equation. So now I'm going to just take a short recap of everything, so that you may remember it. Plus half 80 square. Okay. Now the first equation was v is equal to u plus 80. You know how you we derived it. The second one was v square is equal to u square plus 2as. Third one, s is equal to v plus u upon t 2. And s is equal to ut plus half 80 square. Okay, now these are very important, so you can note it down. And now I'm going to just end the video, because today's topic is finished. That I was going to explain you all the 4 equations, and I have explained you that. And if you have not understood it, so you can also comment and tell me, so that I can just explain you again in another video in a very better way. Now, and in the next video I am going to just continue this topic, because this motion 1D is not a small topic, and it not only comprises of all these 4 equations, but it also comprises of many other things, like displacement is equal to the area of all that. We will get into that in some days, or 5 to 6 days. And I am going to also talk about motion 2D and 3D after a week or so, so that you can understand it. So thank you for seeing my video, and if you like my video, don't forget to subscribe my channel and also like it, and also don't forget to press that bell icon. Thank you.